Well, welcome everyone to this Young Medical Delta Symposium, Designing with Diversity. It's good to see a full room full of real people, finally. We have organized the last few years many events which were offline, so it's good to finally have a real audience. So thank you all for coming. Today we have a full program, but first I would like to tell you a bit more about Young Medical Delta, the organizers of this event. For people who don't know us, we are a board of students, master students and PhD students, who want to bring people together who have a passion for medical technology and allow them to further explore this passion. How do we do this? We do this, for example, by organizing events such as this symposium, but we also organize a hackathon and even a thesis awards. So if you're interested in these kind of events, which I think you do, otherwise you wouldn't be here, please follow us on the socials of your choice. You can find them, the QR code on the banner, and then you can stay perfectly up to date about our future events. Besides that, we also have, as Young Medical Delta, a connection with Medical Delta. And Medical Delta is also present here today. And therefore I would like to introduce to you David de Glint, who is from the board of Medical Delta. So David, could you please tell us more about what you do? And
well, thank you, Jasper, for introducing me, and it's an honor to be here. It's a nice opportunity to be here. As a matter of fact, I'm not used to it because I'm used to a screen, so I'm looking at real people. That's not what I'm used to, but it's really nice to be here, and what I heard, it's sold out. So good for you, good for the organization, well done. But you, Jasper, and your Young Medical Delta audience, you and we, as Medical Delta, we share a passion, or at least an interest for medtech. I'm really looking forward to the presentations today, the discussions, and of course the drinks afterwards. But let's first tell something about Medical Delta. Jasper, you're told there is a connection. Yes, there is. Well, what is Medical Delta? For those who don't know it, Medical Delta wants to realize sustainable care with technological innovation. And Medical Delta brings together 3 universities and 2 medical university centers, and also 4 universities of applied sciences. So that's a lot of organizations who work together. But they don't work alone. They also connect to governments, companies, healthcare institutions, and a lot of other parties. So as a key player in the life science and health ecosystem, we want to create impact. Impact on people, on care, on knowledge, and of course also on the regional economy. And we do that through interdisciplinary research. We have 15 programs, but not only those programs, we also have living labs, and we also have field labs. Together we contribute to needed transitions in healthcare. And as I believe, and I hope you do believe, technological innovation plays a major role in this. But Medical Delta also invests in talent. And you, Jasper, you are one of those talents, but not you alone, of course. All those involved in Young Medical Delta. We see them as the talents, and we see them as our future. You as a young professional, or you as public, you represent part of our future, and it's very, very important to invest in this future. And this is the reason why we're here, because we invest in you as an organization, not only by money, but also by people. And I just want to pick out you, Lian, because you can stand up, then they see you. Because Lian is one of my colleagues, and Rosa is also a colleague of mine, and I have Marit, who is not yet a colleague, but will become a colleague. So almost whole the team is here. So 3 innovation managers are present, and they all help to thrive the ecosystem. But especially Lian is connected to Young Medical Delta. So this is a short introduction of Medical Delta. So can I give the floor back to you, Jasper? Thank you.
Thank you, David. So I think perhaps we have heard enough now from Young Medical Delta and Medical Delta, and I think it's time to move on to the program where we, of course, came for. And for that, I want to introduce Irene. She is our chair of today. Also, she is assistant professor at the TU Delft in healthcare and safety. And today she will guide you through the program. So please give one big applause for Irene.
Well, thank you, Jasper. The applause is for you, actually. Can everybody hear me through that microphone? Yeah, okay, good. Well, I would want to welcome you to this very important and very interesting topic. I will tell you a bit more why I was immediately willing to do this chairing. I'm originally a surgeon, and I worked as a surgeon till last year. And when I started my studies 30 years ago, I told my peer group, well, I want to be a surgeon. I was 20 years old, and I was very ambitious. And then they said, well, you are a girl, and you do not have the right background, so forget about it. That's what I believed for a long time. In the end, I did manage to become a surgeon. When I was working as a surgeon, I started working in science as well. And in science, I did a study, and then I noticed that the data that we use to base our the treatments on are not always the data that fit to the patients that we treat. And it almost became an obsession to me, and I started a fight. I started a fight with my colleagues. I told them, to hell with evidence-based medicine, we really need new research methods. But 15 years ago, that was a guarantee not to get your articles published. We did get them published in the end, but this topic has been with me for a long, long time. And I think we've already come a really long way, but there's still a lot to do. And that's where researchers who really made it their own topic, I'm on safety in healthcare, which also considers the diversity and inclusion as something that is essential to make progress in healthcare. But they are the ones who are really doing some research topics. And we will start off with Esther Bron. No? No? Different one. We start with Edwards. Edwards Villaronga. He's an assistant professor at the E-Law Center for Health and for Digital Law at the Leiden University, and he has a really interesting topic to tell about robotics and healthcare. I'll give the floor to you.
Yeah, thank you. I am the first guinea pig. Sorry, shall I close this? Yeah, now. Okay, awesome. So hi to everyone. So today I'm going to talk about diversity considerations for healthcare robotics, and I'm going to give you a little bit of an explanation of my work and how diversity sort of appeared as an important topic. And that was not like our main research, but that in the end, like we found that was really important. I'm going to talk about like the framework a little bit that we looked and accounting for diversity. Is it okay? Or yeah. So we are working with exoskeleton technology that if the video decides to work, will show you that. Let's see. No, it's not working for some reason. Well, you can, barely see it, so for some reason it's not working. Well, it's not working. It's not important, but basically like exoskeleton technology are robotic devices that are helping wheelchair users to stand up and walk again. And the technology have been advancing so much that right now they are really not very bulky, and they also help patients to go and climb stairs. And we are part of a European project called Eurobench, in which they are trying to have a look at the different robotics that they are being developed in this arena, and they are trying to develop different safety measures and also standards, so that then all the different companies, they create technology that are ensuring that the minimum baseline for safeguarding the patient, it is fulfilled. And within this project, together with Carlos and Hadassah Drukar, we've been working on a project that is called Propelling, and we call it Pushing Forward Robot Development for Lawmaking. Now, the reason why we are doing this project is because they are creating different testing zones in which then different developers can come and they can test their robots so that they can improve their robotic devices. But we stem from the idea that those testing zones could generate data that could be policy relevant, so that maybe we could gather information from those testing zones and use it to change the policies. Because as you may imagine, like the laws that we currently have do not really reflect the technology that we also have, because like they were enacted in a moment in which technology was not there yet, and that it was difficult to foresee what were the risks that this technology would pose to society. So in short, we're trying to use science for robot policies. I assume that the next video will not work either, which is, but basically what we are trying to do in that project is to looking at the fear of falling. So wheelchair users that are being tasked to stand up and walk may be afraid of falling, and we want to know a little bit like what is the impact that this fear, that these cognitive aspects impact on the safety of the user. And also, we want to look at protective stops. Any robots have a sort of very big red button in which you can stop the robot motion. But then we wanted to do certain experiments in order to understand how these protective stops work. Because if you can imagine that a person that has not been working for 7 years and then stands up and then walks, and then it is about to fall down the stairs, for instance, and then you stop the device, you want to make sure that then, even if the robot stops, it's going to stop in a way that it's safe for the user. So we started those experiments, and again, you cannot see the video, which is... yeah, you can see the slide, yeah. So, yeah, for some reason it doesn't work. Yeah, it doesn't matter. But then in this way you can see at least the image. So we invited Joseph Luis. He suffered from a stroke and already 7 years ago, and even if he believes that it was just 8 months ago, and we invited him to come for the experiments. And he came with his family, and also his son Jordi tried the devices with us. And well, you cannot also not see the, for some reason, not even like the slides function. Yeah, so I'm so sorry, but let me see if I can log in into my... that's why it's not working. Sorry. It's just because the images are not even... I can create a hotspot if you want. Yeah?
If I refresh the page?
Yeah. Oh, okay. Oh, that's great. Sorry. Let's see if this works. Oh, you see? Oh, perfect. Good. Well, so as you see, like technology is not really working, and if if now the connection is not working, like imagine like what happens if you are on a robot, right? So this is the fear of falling that we wanted to ask, because basically when you are like working with a robotic exoskeleton, you may be able to fall, and that it is an action that you cannot change. So, yeah. So Joseph Luis came, and then like he also came with the family to do the experiments, and also Jordi started doing them. And then we also had like some female subjects, and for the female subject, it was Hadassah that was trying the device. And then we started realizing that the device was not working properly. The device was like to the maximum of its capacity, and you see that Hadassah is not overweight, and it started like doing really different noises, and it seemed as the device was about to break. All of the women that we had in the experiment, they were complaining that it was hurting the device. And then we sort of started thinking, okay, what happens in here? And then we started looking at the data, and then the data started revealing different parameters with them. So the female subjects were revealing that they had higher stress levels, but they were also using much more energy in order to perform the task. And we thought, well, that could be something relevant for a sort of policy change, no? Because then you say, well, if female users require more energy and they also are more stressed, maybe we can design the devices in a way that we can mitigate those risks. But with them, we started like trying to do the experiments with the non-healthy subject, as they call it, and then we realized that the test bed was largely not prepared to accommodate the needs for someone that very much needed the device. As you can see, many people were behind him, and like we were like very much like trying to hold him so that then we could ensure the safety of the operation. But it was really difficult, and then we thought, wait a second, if these devices are meant to help these people, how are we having tests with just healthy patients and with healthy users? How are we going to ensure that non-healthy users are capable to walk with them? And then what we did, we said, okay, let's look at the framework, let's look at the law. We come from the School of Law, and we wanted to look at it. And for these type of devices, there is a standard that is called Safety Requirements for Personal Care Robots. And when we started looking at it, then we see in the introduction that future editions of this standard might include safety requirements on particular types of personal care robots, as well as more complete numeric data for different categories of people: children, elderly persons, and pregnant women. And to me, like that sounded that somehow parts of this population were sort of reserved for like the future. Like we were going to provide safeguards for these people at a later stage, but not now. So the standard like provides safety requirements for different robots, for mobile servant robots, for person carrier robots, and also for physical assistant robots, no? Like the exoskeleton that we have seen. And basically this is because safety or the threat to a physical harm, it's always ever present. And if we are using these devices, like it is normal that we have safeguards in place that are going to ensure that the user that is using them, it is safe to use. The problem, as we have seen right now, is that this standard did not really take into consideration diversity aspects. And when we look though, like with users that they are using different exoskeletons, we see that it is true that the context of application, it is different, no? They were born like for military purposes, and they are being used in the industry, but now they are being used in rehabilitation, and we see both that it's male and females that they are like using these devices. But we also see that there are children that might benefit from these devices. And when we think about children and pediatric robotics, we need to think that children require different type of safeguards because they need to learn how to walk in comparison to adults that might need to learn how to restore a lost function. With a colleague of mine, we worked on this, and then we started like exploring that basically exoskeleton users come in different shapes and sizes, different age, and also different health conditions. And that because of that, if we are going to design a technology that is going to fulfill their needs, all of these aspects may play a role into the safety of these issues. In 2020, after 5 to 6 years, this norm, this framework, this law was revised without being updated with respect to this, even if in 2014 already was highlighted the need that different users may require for that. And just like to finish, basically what happens is that accounting for sex and gender considerations makes actually better science. And there has been like a lot of attention into this in the European Commission for funded projects. But you know, or if you don't know, like we know that female populations, like they have been like completely disregarded over history, and there has been a lot of attention lately on how dummies and the bodies that they were used, they were males, and for that the accidents in road traffic where women would be less protected, but also there's not that much knowledge on like how drugs also affect like different types of populations. And this brings us to the idea that also for robotic technology that they are meant to help users, that they might have like different hips and that their anatomy might be important, might require like to have like this attention. And that this should be not only at the exoskeleton design, but also on the testing zone where we are going to perform these experiments, but also the laws and the technical standards, no? So that then, in a way, people from my field, they are usually very eloquent into pointing out how robot developers are not taking into account certain considerations, but at the same time, then when they are looking at the laws, then the laws are not also giving response to them. So just takeaways, and sorry that they didn't really work the videos, but the gender and sex consideration are not always taken into account in exoskeleton design, but we start to see that there are differences between males and females, at least for now, but there should be also more attention into other users like transgender, for instance. That tests are run primarily for healthy subjects, but that some of these technology are meant to be used for non-healthy subjects, and that these, their disability is going to affect largely on like how they are going to use, and that is a safety parameter that should be taken into account. And that test and evaluation methods have not been yet implemented broadly in different body types, and that the standards that govern safety should have explicit recommendations to integrate safeguards for different categories of people. Just in our field, what we are going to do is actually in 2 weeks we're going to Madrid once again to gather more data on these aspects. We also want to know to what extent diversity plays a role in safety, and like how this link might be overlooked by current standards, and try to provide recommendations for ISO so that then like it could be renewed. And then we will just like do other tests on fear of falling and protective stops that actually, that was what we wanted to do in our research, but that then we sort of like encountered all of these diversity considerations that were not taken into account. So thank you so much for your attention.
I have time for one question from the room. All the other questions you may hold because later it... Like this? No?
Yeah.
Yes, yes. We will have a session at the end where you also can ask some questions, but there's room for one question. So who can I hand the microphone? No questions yet. I have one question. Yes, you have a question.
How much of a role does length also play in your design? Because I think, of course, when you look at gender, women are generally less tall than men, but
Yeah.
in general, length, is that also a big...
Yeah, so how the exoskeletons are being designed, usually they take into account the length of the bones. That plays a role, but what we realized is that actually what was a more determinant factor was the hip structure, like, and how that is different from the women. And then what we see is that these differences are not enough for making the devices adjustable, because actually they were adjustable already, but they were really not working properly, no? So in a way, that's what we are gathering is that there needs to be a sort of redesign of exoskeletons to really understand what are the main aspects that need to be considered, no? Because also women have the breast, and that also like pressures them, like in here. So like basically this part of the torso, even if the length of the femur you have it, like then all of this part needs to be taken into account.
Thank you.
No, you're welcome.
Thank you for your question. So hold your questions for later on. Thank you very much, Edward.
No,
and we would like to go on to the next presentation. This time it is from Esther Bron. She's an assistant professor at the Erasmus Medical Center from the neuroimaging, and she will tell us about can AI help in diagnosing in real patients. I give the floor to Esther.
Thank you for the introduction. I hope my microphone works. Yes, so with the light on designing with diversity, I want to take you to the difference between research data and whether AI actually works for real patients. So starting with a bit about my field of research, which is radiology. I work here at Erasmus MC for the radiology department, and we're interested in medical imaging, in my case mostly medical brain imaging, and developing methods, AI methods to extract quantitative measurements describing the function and the structure of the brain. And not only that, but also using artificial intelligence, machine learning to, based on these measurements, based on the images, make a diagnosis or do some future predictions of future outcomes in the patient. So that's the background, developing AI based on imaging. And this is, in this field, a lot of research on machine learning is happening. Many methods are being developed, but these methods are not finding their way yet to real clinical practice. They're not helping mostly real patients, real doctors with the problems. And that's something I want to dive into you with today. And I want to start that with an example from the pandemic. So 2 years ago, start of the pandemic, first data sets of COVID patients, CT scans became available. Many AI researchers jumped on top of that to develop diagnosis and prediction methods. And then later that year, a review was published, Wijnands et al., and this popular news article was written, title, "Hundreds of AI tools have been developed to catch COVID, none of them works." And so to show a bit what happened there, so a few quotes from that paper is one example. The AI was trained on patients with, on CT scans of patients with COVID, but of course to train the method for diagnosis they also needed some controls, so they took some CT scans of healthy people that were available, but those turned out to be kids, and the AI worked very perfectly of course on this training data, but learned something different than the target. Another example from that paper is predicting the risk of COVID from the scan, but as more severely ill patients were more likely to be scanned in a laying down position. So the position is a good predictor for the severity of the disease. But this is, of course, not what we're interested in. And one of their conclusions was that many tools were either developed by AI researchers who didn't maybe notice those biases going on, or were developed by medical researchers that maybe knew it but had no idea how to solve that. So these were two quite extreme examples. I think in most cases were more subtle. And the main biases of the main problems here could be summarized by the prevalence of the data used to train the AI methods not being representative of those of the target population. So being undersampled or oversampled patients compared to the hospital situation where you would apply it. The controls not being representative, so I showed two examples of that. And the inclusion or the exclusion criteria of the patients being not representative. And so this might be an extreme case, as beginning of the pandemic there was like high pressure on getting the first papers out as quickly as possible. But maybe this might be exemplar for the big of the field. So I would like to take this to my field of research, to dementia. So worldwide, 50 million people are living with dementia. The majority of those patients has Alzheimer's disease, and early diagnosis is still a problem in this disease, because the disease is so complicated, many factors being involved, many symptoms, many ways the multiple diseases underlying dementia can develop. So on average it takes a couple of years before a first diagnosis is being made. And this diagnosis is important for giving the right care to the right patients in the right time, and also for research into development of new medications, so that we have at an early phase accurate diagnosis. So how machine learning methods are being trained here, mostly based on imaging data, so where we can measure like how the brain shrinks, to say it simply. And that imaging data is often combined with like clinical data from cognitive testing or lab tests to make a diagnosis or to predict a future outcome of dementia. And this is a very big research field. It really took off from 2008 onwards with those two papers, and that coincides with much more data becoming available. So then a large multi-center study, the APNI Alzheimer's Disease Neuroimaging Initiative multi-center study started, and many papers, I think like 70% of papers on this research is just on that one data set. And the performances are quite high actually. So on average an accuracy of 90% to separate Alzheimer's patients from controls. But how would this perform on real clinical data? So APNI, as I said, that's used a lot. And I recently did a research project to look into how those methods trained on this large APNI data would perform on the Parelsnoer data, so data of our Dutch university medical centers. And that was the first time that that data set was used for that purpose. So these are results from that study, a lot of different comparisons. So in the circles is the main message. So on the left in the background is the validation result on APNI data, and then in the middle we have the result on Parelsnoer. And actually we were happy or surprised to see there is a drop in performance, but it was not so big as we expected. And one of the reasons, the major thing maybe explaining this drop, is the difference in patients, whereas in APNI there is healthy controls as the reference examples. In clinical practice you would never have a completely healthy normal person entering your memory clinic, but it would also always be people that have some cognitive complaints, which are in the Parelsnoer dataset, but still and not a very shocking drop in performance. And I just told you that in this field there are over 1,000 publications on this topic. But still, recently with my master's student, we looked into papers that did an external validation, and we could only find 10 papers. So yeah, that already is quite shocking. That I think it's coming more, so all these papers are relatively recent. But external validation is very limitedly done. But the drop in there is some drop in performance on average, but it's not that shocking. But still, I think most of these claims for COVID, they're in some way present in dementia research as well. So still as I said, most research is being done on a couple of dominant data sets that are mostly case control and have another prevalence as the memory clinic. Mostly it's done on healthy controls, which may be good for training, but for testing and validation, we would like to see how it performs in a real memory clinic. And regarding inclusion and exclusion criteria, I think there's also a mismatch about the research data that we use for training and development of that methods and where they are being applied. So age is a confounder of dementia. At a higher age, you have a bigger risk for dementia. Also so dementia does happen in a younger age, and then diagnosis is more difficult because it's maybe often it can be confused with like a burnout or psychiatric symptoms, for example. And age also differs per cohort, per population, as different hospitals. So older people are most often diagnosed by a GP, by a general practitioner, while younger people are more likely to go to university medical center. And also regarding comorbidities, there's another disease that you have in addition or next to your dementia, for example, that differs per population. So people with comorbidities are less likely to be in a research data set, but they are likely to be in a memory clinic, for example. And because research studies, they may exclude people with comorbidities. And I have one illustration of that, and that is a vascular comorbidity, which is very common. You can see it on the scan on the right. There's these white dots in the middle of the brain. Those are white matter hyperintensities, which are a sign of small vessel disease. And in our research data set, so the APNI, there's many patients. Most of the cohort has no to very little of those white matter hyperintensities. Well, in the Sunnybrook dementia cohort, so a memory clinic population, this comorbidity is a lot larger. So to summarize, what my opinion is that technology is there. There's so many methods published. Most of them work, but what we need is real validation and a collaboration between medical researchers and technology, AI researchers, and we need the representative data of clinical memory clinic data to take account of bias and to set the next step here. Thank you for your attention.
Well, again, a very impressive presentation, Esther. I think you show here that it's not a small problem, that it actually reveals how we've been creating a paper reality in healthcare somehow. A paper reality, I mean with that, that we've created a reality that is not as it is in real life. And I think a lot of doctors would agree that what's been written in trials and what's been written, of course, has a solid base, but it often does not fit reality on the working floor. I think your data showed that as well and makes it more visible than ever before. How do you think we can solve this? What should we do? What kind of data, and how could we get the right data to get this to work? Have you had any idea on how to approach it?
Yeah, so it is not going to be easy on an organizational and a legal and a level, but the data, we are collecting the data of patients, so we need to collaborate and work on a way to be able to use that data that we are collecting every day in clinical practice, to be able to use that for research. And we can do that, but I think that needs more effort. And maybe bring AI, so yeah, AI researchers would like a data set that's available for them to download. Yeah, but we need, so it should be a requirement for AI researchers to make an effort to also validate on real clinical data. Or that should be that should get more attention. Yes, so we should build infrastructures able to bring the methods to those clinical data, as clinical data often cannot leave the hospital. Yeah.
Actually plea for research groups working also together in creating a kind of platform where you have open data for open science.
Yes.
Where everybody could extract data from. I know with Omics data that they already use it. I'm not sure if that's...
Yeah, so I think that's one good thing, but I think the data of the clinical data, I think making that open data, that's probably not going to be possible. So there we need to revert it the other way around, make a platform that can bring the methods to the data and leave the data where they are. Yeah. But still a platform.
Yeah, thank you. So there's a lot of work still to do.
Yeah.
I have some room for questions. Yes.
Thanks for the presentation. I have a question about the dementia. Because I found in the recent years, the research is still mostly focused on the physical design. It's not from the mental design. So I'm wondering, so these diagnosed images is from the mental side or still the physical side? And also just assume we can design some new things based on these diagnosed images. Is that we can just evaluate from the mental side or just, yeah, this can really be useful for our patients. Because for the people who got the Alzheimer or the dementia, they cannot really know this design is for me. We can only evaluate from their family or some others. So
I didn't completely get the first difference that you say. Is that medical or physical?
Oh yeah, I just mean like the most design is focused on the physical use. It's not from the mental perspective. Because for the people who got the Alzheimer, maybe their mental age is quite young. We cannot really know their thoughts or some other things. So I'm wondering our design, this design, I mean these diagonized images is still relevant to the physical design or the mental design. I mean, we consider about their both physical condition and the mental condition or only physical condition or just mental condition.
Okay, yeah, so so the images, of course, measure the physical aspect, so the structure of the brain, and in some way we can also measure function of the brain with MRI, so not with the structural image that I showed, but we can measure like blood flow to the brain and those more functional aspects. But the mental part, so this imaging is just one part of the diagnosis and one part of input to AI. There are cognitive testing and behavioral scores. So it will be combined, it will be multimodal. We need, so that's also how currently diagnosis is done in multidisciplinary. So imaging is part of it, but we also need input on the mental part of it. Yes.
Okay, thank you.
Yes.
One other question. One other question? Yes.
Okay. Thank you. It's a very insightful presentation. Thank you. And I have like similar questions like girls just asked. It's more like, because recently I also do a small research about the AI-enabled system, how the cardiologist can trust it, or how the patients can trust this kind of AI-enabled system. So I'm not sure about right now for the AI system for medical industry. It's more like from the beginning to the end is kind of systems the medical doctors can interrupt it and get the results directly, or the systems right now doctor can kind of like enter some symptoms by themselves, and it can change the AI system to diagnose the patient's situation. I mean, I'm just curious what kind of situations right now for AI-enabled system in medical industry.
In industry, so I don't know really about cardiology that you were referring to, but for neurology, so the domain I'm working in, none of these real multidisciplinary AI methods, machine learning methods that combine like high dimensional data from images, they are not yet used in the clinic. So quantification is making their way in the clinic, so helping radiologists to more precisely or more quantitatively measure like the volume of a brain structure. So AI on that part is making their way into the clinic, but these fully integrating diagnostic systems, they are not yet.
Thank you.
Okay, thank you for your question. Thank you, Esther, for your very, very nice presentation.
Thank you.
Thank you. We'll have a short break right now. I think we can conclude that we can use a bit more diversion in the design of our research methods, in the design of our studies, and in the design of our technique. And I think after the break we will try to find some solutions. No pressure. So it's about 10 minutes, 10 to 15 minutes break, and have a drink. Thank you. I hope. Thank you all. I hope you all had a good drink, and we will now proceed with the second part of the evening. I would like to invite Gennady Roshupkin to the stage. He has the most diverse background I've heard, at least in knowledge. He's an astrophysicist. He is also in computer science. He is in imaging and genetics, and he will tell you about epidemiology. And I can tell you it's a completely comprehensive talk he will give to you. So it's to you, Kennedy.
Thank you so much for such introduction. So I'm really happy to present today. And I chose quite a provocative, I think, title about like how epidemiology can save your AI career. For first thing is that I think that the talk I'm going to give you, it's not only about your, let's say, research career and how it can be applied in research, medical, technical research, but also actually outside academia, in industry, in companies. And I will make some examples today. And second part, what is for me is actually a bit strange, because if you would ask me 5 years ago that I would give this presentation, I wouldn't believe this. It's like, because I myself more on AI part, so I'm doing in my research group, we're doing a lot of AI, machine learning, and genetics and medical imaging. But seeing the struggles of my colleague and also based on the publications and also different news, I just realized that I'm actually really lucky that I did my PhD partly in the epidemiology department and learned a lot about the epidemiological principles. So and today I want to give you some sense of how it can be useful for you. And of course, to start, I want to start with history of epidemiology. And history of epidemiology actually starts with this person. It is Jon Snow, but not the one from Game of Thrones. That's one actually a real physician from UK. And he's famous because he solved the puzzle of the cholera outbreak in London. So this is the point where the modern epidemiology starts. And he did simple things. So it was outbreak, a lot of people were dying, and it was like a lot of wild hypotheses why it's going on, starting from some like fluid from the river which goes in the night and people breathe it and die and all the things. And he did just a simple thing. He just took a map of London and put the cases, as you can see, red dots here, where the person lived and died because of this outbreak. And what he found actually, that there is like epicenter of this. And that was just a water pump around this, and he realized that actually the disease comes from the water and some bacteria, etc., etc. It was really difficult to convince back then. There was a lot of famous and other scientists and couldn't believe this, but data told for themselves. So, and he saw this problem. And that's really, so that's basically from that point, the current epidemiology starts, like it's developing. And I would also recommend, there's a small title, I hope you will share slides afterwards. There's a really great book, A History of Epidemiological Method and Concepts, by Professor Alfreda Marabia. So it's really great, a lot of stories about also like how they proved the lung cancer causing by smoking, etc. So it's not such a simple things. It's really amazing. But what I want to tell you that, okay, that epidemiology is actually the study of what is upon the people. If you just translate the epi, demos, and logos, it's like among people and to study. And you can conclude that epidemiology actually study analysis what, when, and where happened in healthcare and disease conditions for the population. So you might assume that epidemiology sounds like it's more about epidemic. So let's say COVID epidemic. So and that actually was really useful. And the examples what Esther told you that would really help to those researchers who would learn, if they would learn epidemiology, to not publish that research. So, but it's also not only about such type of epidemics. Let's say if we're talking about dementia or like stroke or heart attacks, it's also epidemic. So, but just slowly going in the population, not as, let's say, cholera or COVID, it's still worth to apply the same principles. And then I started that the counting of the epidemiology from the mid of the 19th century. So because since that, this field started to accumulate the principles and ideas how to make your research, how to build your research, how to make conclusions. And it's basically more than 150 years of experience and expertise and a lot of papers published. So basically, if you look at the diagram of the evidence of the study, so that in the core of the epidemiology is about how you design your study. So you can start with just case reported in clinics, and you can go high in the cross-sectional studies, case control studies, some population-based studies, and finally like randomized control studies for drugs, etc. So, but that's of course applied again. So starting from clinical and healthcare research, but you can use this knowledge in any field outside this, and I will show you examples. So the basic idea of the informatives of the study, of course, it starts with your domain knowledge or prior knowledge. Because if you just, for instance, expert in AI, and you got data about the COVID, or actually also dementia, downloaded open source data set, so it might not the best approach for you to do the analysis, because you might know something about method, like AI or machine learning, but you don't know anything about dementia or COVID. So, and then your results actually wouldn't make sense, or you really have to consult a professional. So, but another thing is about accuracy of your study. So there are two components. First is validity, so about the systematic error or bias. And second one is about precision. And this is an example that shows, I hope you can see, so this is like aim, where you can shoot with darts bullets. And first example, you see that's the perfect case scenario. You have all the shots in the middle, so you have zero bias and really good precision. So in this example, you have quite accurate shots, but the error or variance is quite high, so the precision actually, in this case, precision is not good. In this case, you have really good precision, but you're really off, so your bias is really huge. And this is a worst case example. You have a really bad precision, but also a huge bias. So and that's when you design your study, you have to take this into account. And you can solve this problem by various approaches. So, but if you start just with the precision, for instance, is one thing. So you want to reduce this like variance and how they distributed your results of your experiments, of your study design. So, but in epidemiology, they already realized it quite some years ago that big data doesn't solve this problem. So it's like there's a saying, garbage in, garbage out. So even if you collected millions of samples with the COVID, with dementia, or with your clients on your website. So if the data design is not good, you have bias, so the precision is quite good, but you can have off results. So that's why data doesn't solve this problem. And just to give you examples about what kind of biases we can expect from not even a clinical application. So the first is like historical bias, so how you collect your data. So, and let's say this is a famous example, coming back to the diversity, from the, so they have such a huge company, they have so many people working for them, and they decide, okay, let's automate the HR process. So basically, let's train the algorithm, read the CVs, and just invite someone for the interview, let's say, just to make it less work for the HR managers. So, and of course, what they did, they trained the algorithm on the data what they had already before. So, and this is like IT company, they collected maybe some years ago data, and what happened that majority of the CVs they trained the algorithm was from the white male, because like 30 years ago, 40 years ago, most of the people in IT was men, so male. So, and of course, what happened that the algorithm they trained was biased, and basically they had to stop to use it because the training and was completely off towards gender. So, but by even like so tens of thousands like CVs, so data, it does mean that if your design study is wrong, so you have the historical bias in this case, then it can really, let's say, your application of your algorithm, learning, deep learning, on any analysis can get wrong. So another example, also actually quite famous. So let's say you want to develop a tool for speech recognition. So okay, what would be the best approach? You just say, okay, we can take audiobooks because we have text and we have audiobooks. There's a perfect case scenario. So what can get wrong? So it happened that, well, that's what most of the companies did. You can see here different labels and their speech recognition. And here is error of the speech recognition. So higher means more errors. So, and of course, most of the audiobooks was trained by the voices was talking with like white Caucasian people. That's why in US, all the speech recognition system went completely wrong for African Americans. That's another example of the, if you make your study and you don't know what you're doing, so something can get wrong. It can get sued later on. So, but that's why, especially for industry, but also in healthcare, it's about lives. So in both cases, it's quite damaging. But another thing, so let's make example bias. So let's say you want to just study or also predict salary based on years, how long you work in the certain domain. That's, you got the data, you just computed the mean value, that looks great, you work more, you get more salary. But unfortunately, if you look at the distribution of the different domains, if you are sportman, if you're in the sport, that doesn't work for you. So actually in sport, you earn more money early in the career than later. So, and that's why if you just compute like mean value, or you input for your algorithm a wrong data without, let's say, additional information, then the whole prediction, the whole model can get wrong. So even before you started with learning about machine learning on artificial intelligence, should design a study in a proper way, and in this case, using like epidemiological approach, basically. Another thing is also common, today covered also by Esther, that, let's say, a lot of research and AI application in healthcare, but also you run your model, well, you tested it, hopefully, and then that's it. But another thing is to improve your validity or remove your bias. You have to test it outside your study. So otherwise, you can't say anything about your model. So this is principles well known for epidemiology, well, basically built on a lot of mistakes and wrong publications 100 years before we even invented machine learning and deep learning. So, and that's really important to take into consideration. And I even made a small summary, let's say, there are terms which are used in epidemiology in artificial intelligence. Sometimes, unfortunately, people like invent wheel. So, and something is already used for years. Let's say like you have in epidemiology independent variables, in artificial intelligence you use features. Then actually also some terms might be confusing because in epidemiology precision, as I said, it's about your precision of your study design and experiment. And like in artificial intelligence, this is a variance. But in the same time, in machine learning or artificial intelligence, precision means something else. So it's more about your predictive, basically predictive value, true positive values. So and there are more and more, let's say, replication, as I mentioned, is you have trained test set or like cross-validation in the machine learning community. But also, let's say now it's become more and more popular to talk about distributed learning or federated learning, while in epidemiological studies, meta-analysis ideas was done already for years. And there are from AI community trying to invent the way how to do meta-analysis for federated learning, but actually you can just grab papers which published 30 years ago and find your solution. So how I want to conclude, actually, I like this quote that everything new is well forgotten old. So that's why you should pay attention what is published before, what is done before in the community, and that's also important to have this interdisciplinary team when you work on some project. So that's what also was highlighted today. And also that ideas what people doing now in AI sometimes reminds me this figure. So let's say also you want to jump into machine learning on AI, you have to learn a lot of things about how to write code, about data structure, about calculus, statistics, and some people jump, and here somewhere should be epidemiology. So, and people jumping over, like, yeah, I know now how to do the research. So, and I can recommend a really good book, Modern Epidemiology, for everyone to read. That's a great read, and you can get a lot of inspiration for this. Yeah, thank you for your attention, and I'm happy to the questions.
Yeah, thank you very much. Very clear presentation, a completely different field. How many statisticians or epidemiologists are here in the room? Anyone who has a nick of going into that field? No, me neither. So thank you. Thank you for your presentation. I was always told by my colleagues that, well, in the future, big data is a solution for everything. And you just convincingly showed it was not. Yeah, the question is, what is the solution? What is a solution, I could better say. If you are looking at the problems with the precision and the validity of your data, what could be a solution, for instance, for Esther's studies, to get her predictive models better?
Yes, I think that Esther also mentions certain things, so also issues in her field. So of course data, as I said, so there are two things. Of course data can help you with certain problem, but it doesn't mean that it can solve everything. So another thing is also to work in the, at least if, well, there's no one wants to learn epidemiology, but at least you have to work in a multidisciplinary team that someone can tell you actually this is not the way to do this, or it's already like known that that's how it works. The same, let's say, with statisticians, right? So if you do some research in clinics and you don't know statistics, you go to the statistician to ask the question. So yeah, so and I think that it's more important to ask the right question. What do you want to do exactly with your studies? So the same with machine learning algorithm and AI, it can be as good as your data and as good as your question. So that's, I think that's, before you start, you should just really right way to phrase it and find the right colleagues or right knowledge to prepare yourself for research. Because again, so right now to write some machine learning code, let's say using Python or neural network, it's just 10 lines of code, right? That's just really easy. Everyone can do this. And unfortunately, that brings this issue that there are a lot of like false fundings, false papers with some research, which just completely outside the field. So, and that's really also like that will bring in AI, especially in healthcare, the same issue of reproducibility, what we have in like social science.
Yeah, so that indeed is a question of very sound scientific knowledge when you start medical research or any research at all. I think that hasn't changed at all. Questions from the audience?
Yeah, you paint quite a dark picture, right? So are there actual examples of things done very well in this field?
In AI?
Yeah, AI and epidemiology.
Yeah. So well, that's of course yes. That's my message was of course to paint it a little bit darker. So then you will pay more attention. If I will tell you that everything is fine, there are just a few results, and yeah. So no, there are a lot. Well, actually, like what Esther also showed in her results. So let's say they're doing this AI prediction for dementia, and it's reproducible in different data sets. That's an example of multidisciplinary teamwork, let's say. And there are still researchers doing this. So application for prediction, I don't know, like skin cancer, like stroke, you name it. So there are papers in different domains, they're quite solid. But again, so we as a research community should also control this, because there are so many papers, so you will have, like, say, soon might have like one good study design paper and then 10 with bad design study. That's what you saw also with the COVID. It became like a hot topic last 2 years, a lot of fundings, and people started to do COVID research who before was doing some I know, children autism research, and then everyone jumped and got money for like how COVID influenced like this topic or how we can predict this. So I think that's the danger. So that's why I want to kind of bring some awareness so that you will be aware of this, and just when you do your research, you will be more accurate.
AI hasn't changed the fact that you should start with defining the right problem and defining the right method that fits to trying to answer your problem. And the fact that we are 100 years ahead doesn't make a difference. Who of you is working with AI? 1, 2, 3, 4, 5, 6, 7. A little bit higher. I can't see it. You don't get the microphone. No worries. About 10 people here working with AI. Who of you does not recognize this problem? None. I think it's very clear that it's a real problem, that we should work on trying to solve it. Who of you has an idea of how to approach or how to try different methods to solve this problem already? Yes. Can you elaborate a little bit on that? Do you want to elaborate on that? Yes, that's you. Yes.
Question also.
Yes.
It's fine. So,
can everybody hear it also in the back? Okay, otherwise stand up, please.
So, before you probably go about framing your problem and question and also to address her issue, wouldn't it be better to, push the medical community to gather more data so that you now have a representative set of, the proportion of the population that has a certain disease, and then to train any of your models, you can sort of make a subset of the data that is representative and use that to train your models.
Yes, I agree. So just to be clear, so when I said this, more data doesn't solve all problems, doesn't mean that you shouldn't collect the data. So more data is always better. I showed this plot with these bullets. So in that was about actually epidemiology, let's say the precision and the validity. But machine learning, let's say you have the same plots showing about the bias and variance, and that's about your complexity of the models and the amount of data, and you have to have a trade-off. So more data can solve certain problem, and definitely you should collect more data. And I'm not completely agree, maybe that can be for the discussion, how open source this data should be. Also due to privacy, but also due to the problem that if everyone can download the data, then everyone can run model with these ideas of the epidemiology, let's say, and publish, maybe not in the highest impact journal, but still publish, and then people start to refer this, and that can be lead to some problems. So, but definitely more data and more an efficient way to be able to run your models if you're in research. That's definitely.
Yes, so not just more data, but then every time you train a model, you can ensure that the data that you use to train it
Yes, you mean like just continuous, let's say, like deployment of the model where you can retrain, let's say, based on new data.
But basically, like every time you use data to train your model, you make sure that that data is proportionate to the actual population rather than just a random set of.
Yeah, yes. But of course, to make it proportionate to the some set, it's quite also difficult sometimes. You know, that's the same. Like for instance, even in dementia research, let's say you don't know about disease. Again, you just download MRI and data, and then you run your analysis, and let's say, because you collected data, let's say from Erasmus and from some children's hospital, from Sophia even. So, and then your algorithm will perfectly predict, but because you didn't match the age of the participant, you know, like you can easily predict age, let's say younger, you don't have dementia, so, and older, you have it. So, I do agree that it should be like a framework where you can easily do this. And this should be taken into control, the study design, let's say.
Yes. May I raise another question? Yes. Because what I experience in business is that we have a lot of medical people who would like to apply data science, because data science is thought to be the solution of everything. And we have a lot of data scientists who do not want to read any book about cardiovascular diseases or any medical stuff because that's too difficult. The data scientists always want to start programming in Python.
Yeah.
Immediately. Today, download the code and run it. We'll see.
Yeah.
But what is so striking for me is that these data scientists and these medical experts, they really don't understand each other. They really don't understand each other. So they're solving things, and the data scientists are happy because they like programming, which is fun. It's nice. If it works, it's really fun. It's nice.
Yes,
you see all
yes.
fancy things happening. But it's bullshit.
Yes.
So funny because I want to respond directly because obviously he's a computer scientist, right? And he said, yeah, I think so. I think so. And the thing is, we need to push people from the medical field to gather more data. That's not how it works. It's not something that you can just easily push someone to gather more data. That means you have to hire another PhD student who has to work 4 years to gather up a cohort to get more data according to all laws, and then you have to transfer it out of the hospital again.
Yeah, but let's not. But because
just to make sure that we don't actually understand each other, because I think it's a perfect example.
That's of course the problem. I mean, that's from both sides. So let's say again. So I'm working. I was fighting. I said that for me it's strange because I'm more AI. And when I started working in epidemiology about genetics, and also I was just like, yeah, let's use some machine learning. And then community, actually also medical community, is quite resistant to something new, and it's like easy. So like, so it's. I do recognize both problems, and of course there should be like a mutual solution. But the problem is, I would say that you don't have people on the top, like companies also, management, who understand at least at the both domains, because you either have manager again from data scientists, or you have in hospital clinician as a board of director. So and then they don't understand each other. So clinician sees, okay, it's like something we don't really care, just do we more care about the patients and safety, etc. And then data scientists, they're like, yeah, give me more with AI. So that's what I struggle with also students. Like if I have a PhD student from Delft, that AI is like a hammer, everything looks like a nail, let's just apply it. So nobody wants to think about it. Maybe you can solve it with linear regression, you know? So, yeah. But I think that's one thing is just converge it, but also I think that there's a lack of people on the high level, like with a boss knowledge. So that's a problem in clinics, I see it also, and also I assume in the industry.
Yeah. Oh, a lot of good questions. Hi, a little response to your question. We have an actual joint degree in clinical technology just addressing that problem. So, and in the new curriculum, which I'm designing with a few of young technicians, clinical technicians, we are implementing a data science line just to address the whole issue discussed, well, from bottom up, but we are addressing this, yes. It's a huge... Well, yes, as an educationalist for the joint degree, And we start the new curriculum and the first data science classes in September. So, yes.
But I think it should go even further because.
Yes.
Yeah.
Yeah.
But I'm sure you will survive. You will manage.
But do you have any legal and ethical models? Because I see that medical technology and these two communities are sort of like, yeah, they do not understand each other, but usually they develop finally solutions and then they say, oh, wait a second, what about the laws? Like, how do we do this? And then, like, all of a sudden, like, there's like, oh, yeah, this is a question. Well, but our model is this. Yeah, but you know, all the GDPR and the medical device regulation. Yeah, it's like, yeah, but like, how do we sort of like put it already like into the market? And sometimes, like,
I think I would say, Tanya, you need another module. It's just another extension of the study. Sorry, 1 year more.
Any of these considerations, like because there's like in the law what they call the data minimization principle. So like in a way, collecting a lot of data not only like for practical reasons, but also because the laws and the privacy of the users are to be respected. And many times it's because we don't really understand how privacy harms people, no? Because well, it's very easy to see how a robot can hit you or how a program may misdiagnose you. But like we need also to think about that well, we've been working about data protection for so long, and that is also for a reason, no? And that it not only involves you, it might involve also like your family and like your future generations, whether you want to know this or not. And yeah, and I think that in a way, like, we need also to have like these discussions also with the law and ethics, because I also understand that from our field, people don't really know how technology works, and like let alone like how medicine works. So it needs to be a sort of three-dimensional discussion, so that we ensure that at the end of the day, who benefits the most is the user and the patient, not one or the other discipline.
Okay, one last question from you. The ones with the microphone can ask a question.
I can add to that. We within the TU Delft, there are busy with making the reflective engineer a thing. It's right now being included in the vision for the education. One of our past program directors is involved in this right now, so we have close contact with her, and this is it's about a reflective engineer, so they need to reflect on the work they do, so the problem you assessed is going to be within that.
Yeah.
Okay.
I just
comment.
I think that it's really important that again, so to have people train in both ways, but again, so it's really important then on the on management level is also appreciated, because you will struggle a lot if you like even from your master program, say you find a job and then you're, let's say, in the company people like don't see it clinical or only on the technical or other way around. You work in the hospital and people see you as so it can give a lot of problems. So unfortunately.
Just one last question from here.
Yeah, well, I want to add some supplements about this data sets, and I think this is also about the openness. Because in the Netherlands, the pharmacy, there are so many different platforms. The pharmacy has the pharmacy, the GP, the hospital, and even the patient. They got the different platforms. So like, and also these platforms has the different ownership, and they don't really want to share this data. But luckily, the TU Dev also is working on the sharing platform. They are trying to define the requirements and yeah, well, design for the future.
Yes, okay.
Well, thank you. We have a little bit of time left for actually our panel discussion, so I would like to ask all the speakers to come forward to have a short recap of what we have been discussing. And actually, I agree that we've been narrowing our studies so much that we actually cannot overview the whole field anymore. It's not an easy task to solve. Yes, very good. We'll stand in front of it. or just keep them straight so we can lean a little bit on it. We hope it holds. Otherwise, people from TU Delft are here, right? To solve the problem. Okay, good. Can somebody switch off that? Yeah, very good. And actually, I wanted to ask Edward one question I found very interesting and important, and that's because that's my hammer. So I want to get back to the safety issues of not being diverse, not embracing diversity enough, and also not being inclusive enough. Because you actually showed very clearly that if you do not take the differences between people into account with designing technology, even if you have a Safe by Design program indeed from TU Delft, that it should be safe by design, but if you do not take differences into account, it still is not safe by design by the user. So how do you think law could help us not only to make it a ethical responsibility or a moral responsibility as it is now, but also that we can enforce it towards companies? How do you think that would be possible?
For me, no, I think we have a mic. Yeah. Oh, yeah. I think that for me, it is also important that these two communities, the medical and the technology, also engage with policymakers and also standardization activities. There are many opportunities to join several chapters in the NEN in the Netherlands, for instance, because what I've seen throughout my work is that the policies are really not tech savvy. Usually they work in a sort of like technology neutral way in which like they talk about general principles, but these general principles are very difficult to sort of like apply in a technology, say, oh, privacy, what does it mean privacy in an exoskeleton or in epidemiology or for dementia patients, no? And these sort of values and also rights really shape in different ways, no? So in my opinion, there's some room for improvement. So it's not true that there's no frameworks and that there are no ways in which we can do that. But I do believe that because these are scientific breakthroughs, that frameworks should accompany them in order to sort of enable the research instead of like being a sort of an impediment, no?
Would you like to reflect on that as a business owner?
As a business owner?
Yeah. Somebody from business.
Yeah, I didn't introduce myself. I'm just fresh. I'm Auke de Leeuw, working for Innovating. It's my own company. I studied also in Delft, so I'm a real technical guy, but now involved in data science and in the medical field, cardiovascular and also medication safety. So doing a lot of projects. Actually, was it a real question you were proposing, or was it just a statement you made?
No, sort of a statement. That usually all of these considerations like come as a sort of afterthought instead of like being thought through beforehand.
Yeah. Do I have to solve the issue or raise another question?
Yeah, of course.
Because it's always difficult to solve all problems in advance, and because you said that you would like to have a tripartite meeting to add also the legal part, but there are so many other parts, also social part, and you can, let's say, elaborate on that much further. So yeah, what I always like is to also to let chaos do its work, and you have to also do the experiments. Just do it and give it a try.
But then we could have testing zones to do so, no? So that then, like in a way, we can not do the chaos with the patients, not directly. Like
I think as a legal guy, you don't like chaos, do you?
Maybe. Yeah.
I could add a little bit to that because some problems you cannot see in advance or you only encounter, and then the chaotic way of working might help. But as a safety expert, I would be really...
Not that I promote always chaos. It's a nice basis to, let's say, a thing.
I agree that in different moments of the development of a technology, certain problems may be more known or unknown, no? But like we should sort of understand that maybe when we could have an idea and then we have a simulator and then we could think about principles like privacy by design, no? Like how we can design the technology from the beginning that is privacy respectful. And then we move to the prototype, no? And then we have like a prototype that might be physical or not, and then that may give some information because we are testing it, no? But then like you guys have like in the young medical, like living labs, and so like that also may give also further information. But the idea is that when you arrive to have a product that you want to put into the market, you really have thought about everything possible that in every layer has, no? And we need, and then in this case you say, well, if my problem is that I cannot see the future, what methodologies can help me anticipate that future? And then try to think about anticipatory design methods in which you can sort of like bring forward this, or you can think about narratives, no? That you say, well, of course, scenarios that they are not, so they are a bit more science fiction in a way, but that help you see how that could go wrong or not.
Okay. Alke, if I would just complete, because I actually agree with you. I just wanted to make a little bit of a
advocate.
I wanted to try to provoke the situation a bit, but it didn't work. Sorry. But actually, I think what you you mentioned a solution to this problem of not being able to anticipate and not trying to block all new technologies with rules because we anticipate on dangers that might not even be there, and actually prevent technology from helping us achieving more safety. So that's actually quite a complex situation. But you gave the solution as well by saying, why don't you approach it in a living lab approach, where you address safety, where you address inclusion, address diversity, address laws, and also governance. Yeah. Right from the start, so that you actually work together with industry right from the start while developing, and this way, in a natural way, achieve the best results. What would you think of that?
I will raise another question. I'm sorry, but because I fully agree, I'm an entrepreneur. Who of you is also entrepreneur? Would like to be an entrepreneur? Okay. That's very good. As an entrepreneur, you have only one concern. Do you know the concern of an entrepreneur? Yes, survive. It's a clear answer. Survive. Not to get bankrupt. And that's really very difficult. So, of course, working labs, try the chaos, try it, try whether you can take everything into account. But there's a limit to it. For entrepreneurs, there's a limit. A lot of startups or scale-ups get bankrupt because they try to cover everything, which is very important, but you will not survive. And that is the difference between science and let's say, the governmental field and the entrepreneurs, because a lot of innovation comes from entrepreneurs, but they have to take care for the money first. So when I work with my people, I say, Monday morning, what can you do? Sales, 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 sales. If that's ready, think and combine, work on the product. But developing a product is sometimes the last thing you do in a week, because you need to survive.
Yeah, but I'm not convinced with this argument when the safety of the users may be at hand, no? Like I might be a patient at some point. I want to make sure that you that developed a product is super safe, no? Like you don't take a plane that it's unsafe because, well, you know, the company was running out of money, was a startup, and like, well, we've seen like how Boeing, like, I mean, if you have seen like Downfall in Netflix, like look at right now, like basically like.
You should all watch it.
You see like how like rushing and like not taking like safety first then leads to airplane crashes.
But I think that's part, or actually I kind of agree, disagree. But that's part of the actually role of the government regulation in this way, because that's not part of the business. Business is, let's say,
I disagree.
But the law is for everyone.
You know why?
Why?
Because it costs Boeing $2.5 billion that they didn't take safety into account. And I know of one director of a shell company in Moerdijk who has a very strong plea that savings can be achieved by achieving more safety. So it doesn't contradict one another, and it's been presented now as if it does contradict, but it does not. It does not need to. But you need to be able to overview the whole field, including the law, but also the entrepreneurship. Money counts, but law and safety counts as well. And unsafe practices is very expensive.
Yeah, but the good news is that I'm an aeronautical engineer, so I studied aircraft, so I'm, let's say, trained in doing everything very precise and legal stuff.
Not accusing anyone, but usually no, but like for
but in this case rely on I don't understand that's your point. So but again, so that's more when it again it costs money for the business. That's why they now more aware, and as an entrepreneur or like business owner, you can be just again, so if you're more precise or just it's your nature, you do this better, but you can't fully rely on the business, let's say in this case, to do something more safely than, because people again might just lack knowledge how to do this properly. So
I understand that from a business point of view, you might be in disadvantage to large companies, and we get that. The problem is that the laws cannot be bended just because you wanted to create a company and you are not big enough to solve such a complex problem. So in a way, I understand that there might be maybe financial mechanisms that support starters or entrepreneurs, but at the same time, like the safety needs to be always the same.
But maybe let me.
I would like to switch subject actually.
Yes, I wanted to ask some other question then.
Yeah, that's what I was wanted to. Because I was actually, when I was looking at your presentations, I thought that you might help Esther. So, do you think you can help Esther with getting her data sound so she can actually make better prediction tools?
I think I have. Yeah, but well, regarding Esther, so that I think we actually work at the same department, so we do collaborate. So that's I think that, and again, so I made example. I think that in her case, what she showed, that's already quite again because we are located in the medical center, and we have a lot of colleagues like from radiology and epidemiology to also to collaborate and work together. So that's I think that. Short answer, yes, but I think that I'm not sure that she needs help.
No, but as the solution, I gave part of the solution on my last slide. We need collaboration. I think that was also mentioned in the discussion. We need the clinical technologist, or we need someone to bridge the doctors and the AI developers. They need to understand each other. So collaboration is one thing. And validation is one thing, and getting more data, I think that's, or getting the relevant data, I think we agree on that. But, and then I think the other solution that I not mentioned, but is indeed in your presentation, is develop the methods that can address bias. And that solution, I do think that epidemiology does play a role there. But I think all those solutions on their own are not going to solve it, but we need to combine them. Yeah.
Thank you. The public may interfere now and ask questions and raise concerns about all the things that have been said here. There must be some now. Yeah?
So the thing I'm wondering about is...
I think it's for recording, it's better to...
Yeah.
Thank you. So the question I'm having is, there is a word that nobody has said, but it seems we've been talking about the thing for a while, and that's standardization, right? So how helpful would it be to have some checklists for people to kind of fill in such that their new products are aligning with the expectations? And is this already being done? And if not, is because there is no standardization, or because it's so difficult to interpret that you cannot actually make a checklist?
No, there are actually a lot of standards, and actually, like the problem of having 14 standards, how we solve this is like a 15th standard usually. The problem of standards is that they are developed by the industry, so usually it reflects the motivations that the industry have. They are very useful, right? Like you can think that everything is regulated by standards, like the USBs, like the electricity, everything is governed by standards. Some of these standards are harmonized, which means that they show compliance with bigger pieces of legislation that they are binding. The problem of standards is that they are usually done by the industry without inviting affected parties. And even if they're, they take unanimous decisions, not everyone is in the table for there. So how I showed here in my example is that basically because affected users are not part of it, because different genders are not even part of it, we create a standard that shows compliance with the machinery directive so that you could get the CE mark, you could get the exoskeleton into the market, but then like you present an exoskeleton that it's unsafe to use. So in a way, the industry got a way to develop standards that show compliance with the laws, but that actually do not prove that the technology is safe. And that is the concern. So it is not
why
that...
Why do you think this is, well, how this happens? Like, would you solve this, or what is the reason for this?
The reason is because how the configuration of standardization activities work. Basically, anyone that pays a fee to be part of that committee can be part of it, and then they together write the standard, and then it's being voted and so. I'm not saying it's a very simplified way, but like usually patient organizations are not there, and they need to be actively involved, but they are not sought this collaboration.
Aren't researchers there? Because I think in medical data and AI, there's also from research a huge drive to get the standardization.
Yeah.
So it's called FAIR data and standards like OMOP for both clinical data and imaging data. I think that in AI, the drive comes from research and not so much from industry for standardization.
In my experience, it's actually maybe both. But the difference is also part of like the money in a way, like the researchers that we take part of these committees to raise our voices, we do that on the top of our jobs. Whereas the industry has, Philips has a person that just goes there and writes and says and vocalizes like what it really benefits them. And I was also part of the European Commission, the revision of the General Product Safety Directive, and then you really see how the industry is really pushing for the changes that might benefit.
But then the question I can ask you also, then what is actually validation? Is it, let's say, if you will be part of these committees or you will be part of these standards, etc., will it be beneficial for your research career?
I contribute to...
No, let's say I'm just asking that's
if there are any incentives for me to do this.
Yeah, so let's say...
Zero.
Yes, I think that's answer the issue. Because for Philips, they can make money, let's say, and that's what drives the person there is. And in the research community in this case, in research, you measure it, let's say, by papers, grants.
Yeah.
And grants also by papers.
Yeah,
so,
my motivation is really to contribute to making society better, right?
I'm saying that your motivation, I mean, we also do as a scientific community, let's say, do a lot of just because you're motivated, and but I'm just saying that the core of the problem might be also in this. That's actually eventually the scientific community doesn't measure it as much as industry, and that's why you have industry take a lead in this.
Yeah.
And that has to be changed then.
And that is the danger, yeah, I agree.
Actually, yes, it's all. Actually, I think it's all a plea for more involvement and collaboration from the start. And I think that there are a lot of researchers and a lot of industries, even lawmakers, who already know that it's in the end profitable for all to have a collaboration from the start. But I agree also on you that reality is a bit more harsh than this naive idea. I would want to ask the audience one last question before we are going to have some very good drinks.
Thank you. I think it's very amazing activity today. So everyone have different perspective to look at the AI issues. So I want to look at these issues from the passion, like because we are talking about the topics is about how to build ecosystems for the healthcare ecosystem. But what if the legal past and also the data science, no problems, the entrepreneur can give some very amazing products for the patients, and the radiology part can diagnose Alzheimer's directly, very quick. But from the patient's perspective, there will be 2 points. One point is every patient would think they are unique. Like everyone will think, I'm unique. I'm not the one can be diagnosed directly from AI. So even though the whole system is already being complete and the dilation is quite high, you don't need to worry about accuracy, but there's still some trust issues between the patients and this kind of system. And there is also the second question is about AI system probably sometimes will over-diagnose or over-predict. So based on these 2 questions, right now, is there any discussions or any solution or strategy to solve these 2 concerns?
I can make a start.
I don't know who can start this question. Okay. Esther,
yes.
Good. Thank you.
Yeah, so I think this is the main point why the collaboration between doctors who ask the real question, who ask for a specific patient, their diagnostic question, that should be the center point for the AI. The clinician itself, or maybe some diagnostic expert, a radiologist, they should choose which AI to make the choice for the specific AI. So there will be many point solutions, AI solving specific questions, and there should be a clinician in charge taking the unique patient into account and linking them to an AI method.
So a researcher, a lawmaker, an entrepreneur, a doctor.
But I think that also just to be clear, let's say this, what you call it mostly about the precision medicine. There's a huge also topic in research that actually is focused, let's say, with drug development, with AI and any healthcare domain. That's more about precision medicine. It's like personalized medicine. So let's say that everyone is special in this case. But of course, with AI, it might be, well, there are different problems, let's say, maybe more older generation, let's say they less trustful for this AI technology, maybe new generation will trust more, so that might solve partly problem. And yeah, so of course some ethical how people, again coming back to the over prediction or under prediction, that's about how you phrase your question, because also there are some papers showing that like you have a good AUC, let's say prediction, etc., but then you actually for the clinical application, you focus on more, let's say, maybe you, let's say, benefit mostly with more false positive, but less false negative decisions. So that's also completely different. So, and then when you build your model, you should also pay attention to this.
I would say that patients should feel unique because they are unique, and that usually solutions are being made for the average because that is very attractive from the return of investment point of view. But we are unique, and all our different characteristics make us unique, make us different, like in responding to treatments, right? You are not just a female, right? You are also coming from Taiwan, your income might be X, you are living in the Netherlands, you are sharing apartment, you are not just a female, right? And all of these aspects are going to make you different in response to drugs, to treatments, and so. And I believe that if AI is so powerful and at some point we can make it work, we need to integrate different aspects also to it, so that then we can give a bigger picture, no? But there are like fundamental, just like to take 2 seconds, there are fundamental differences that, for instance, are not really taken into account. So like, people talk about gender, and then you say, oh, that's male and female. But gender is different than sex, no? Like, and when sex, we have male, female, intersex.
Tricky subject.
No, I'm very confident with the subject. But gender is about also your perception of who you are, no, within the gender. And then what happens is that gender classifier systems use sex as a parameter in order to classify you as male or female, already like disregarding the intersex community, but also disregarding the fact that we cannot objectively identify things that they are inherently subjective. And that's why many models that they are working on emotion recognition systems or gender classifier systems are prone to errors, because basically they use different parameters, like that they are more like within ourselves, no? And when we think about this, and then we think about gender classifier systems working in medicine, then we need to understand like how accurate they might be, because errors in algorithms that support health-related outcomes may have fatal results, and that is totally undesirable.
I think you summarized in the beginning very clearly the uniqueness of the patient should be the starting point and not the end. I would like to give the last word to Auke.
Yeah. I'd like to tell a little a dirty story, but before I do that, I need to ask: are there any students of Professor Reinders in Delft? Then I have to be careful. No, okay, that's good. He's a nice guy. I know him very well. We had a drink just like we will have in a few minutes, and he really destroyed the drink. What did he do? We were sitting together. He is a data scientist. He's professor of data science with some medical guys, PhD students, a cardiologist. And I said all of a sudden I wanted to talk about the subject, data science and medicine. I said to the data scientist, if you make your Python program, why don't you build your Python structure with random forest and convolutional neural networks, whoever knows, like like it is built in human being. So look at the, let's say, how the heart works together with the autonomous nervous system, and build your network similar to that. Why don't you do it? You just build something in Python which doesn't have anything to do with the physiology of the heart and the working of the heart. And the professor said, and that's where he destroyed the drink, because we were sitting in the garden of the cardiologist and he paid a lot of money in drinks and nice foods. He said, because I think that the cardiologist does not know how the human being works. He doesn't know. He doesn't know. I said, you're destroying the drink. He's sitting over there. No, he said, did he ever see the heart working in connection, the interaction with the autonomous nervous system? But the cardiologist said, yeah, but it's in the system, it's in the scheme. We all learned how it works. Have you ever seen it? Have you ever seen it? You have never seen it. So, please, trust on data science, because we will work on an individual. We will measure, we will see. Forget about the medical stuff. So that's where he completely destroyed the drink, and I think now it's ready for drink.
Thank you. Thank you all. Yes. I think the bar is open now. Thank you.